Hey guys, I mentioned I was going to make one more video to walk through another example with a different variable so you guys can have a little bit more help doing your online activity. So this will be a lot quicker than the previous videos, I promise. Here we go. All right, let's say that we want to know whether someone's partisanship predicts how much they like Hillary Clinton. So now we have two different variables. Look over here in our code book. Our dependent variable is another feeling thermometer, but this time for Hillary Clinton. So it's 0 to 100, so it's like 101 points. People that rate her a 0 really, really hate her. People that rate her a 100 really, really like her. A 50 is completely neutral, and then there's lots of different ratings that are somewhere in the middle. Our partisanship scale ranges from 1 to 7, where a 1 is a strong Republican and a strong Democrat, and a 7 is a strong Republican. So I want to show you what that looks like, because this is a very typical way that we measure partisanship. Here's the 7-point scale. Down here, a 1 is a strong Democrat. Someone who's a 2 is like a weak Democrat. Someone who's a 3 just leans Democrat. A 4 is an independent. This is someone who leans Republican. A 6 is a weak Republican, and a 7 is a strong Republican. So as we move up the X variable partisanship, people become stronger Republicans. So that's what that looks like. Okay, let's go through the interpretation. Let's look at the constant, which is right over here. Here's the coefficient for the constant. So we would say before partisanship is taken into account, so partisanship is set to 0, the average feeling thermometer rating for Hillary Clinton is 87.28 degrees. Before X even comes into the picture, before partisanship comes in, the average rating is 87.28 degrees. Okay, now let's interpret the independent variable party ID. So as you know, we follow a formula every single time we interpret an independent variable, and the formula sounds like this. For a 1 unit increase in X, the dependent variable goes up or down if it's negative by fill in the blank units. So let's just take that formula and apply this example. For every unit increase towards strong Republican, so going up 1 towards strong Republican on the scale, the feeling thermometer goes down by 11.34 degrees. That makes sense, right? As people move up the scale, for every unit they go up the scale, moving towards Republican, they like Hillary Clinton less, 11.34 degrees less. That makes sense. People who are Republicans would like her less. Let's see what that looks like. So here is our scale from 1 to 7. So going on average from a 1 to a 2, so from a strong Democrat to a weak Democrat, her rating goes down by 11.34 degrees. For another unit increase, going towards the other end of the scale, another 11.34 degrees. If we go up another unit, going from someone that leans Democrat to an independent, it goes down another 11.34 degrees. So that continues until we reach the end of the scale. All of those 11.34 degrees, that actually adds up to quite a bit. So the entire impact of partisanship is actually very big. We would take 11.34, add it up a number of times, and then we get a very big difference between people who are strong Democrats and people who are strong Republicans. Okay, but is that a statistically significant relationship? Now we have to look at the p-value. our p-value is 0.000. That's very, very small. It's the smallest you're going to see. That is less than all three of our alpha levels, or the thresholds that we talked about in the previous videos. Yes, it is smaller than 0.001. It is smaller than 0.01, and it's smaller than 0.05. So we would say partisanship affects how much people like Hillary Clinton, and this relationship is statistically significant where P is less than 0.001. So we would say we reject the null hypothesis. Remember, the null hypothesis here would be that partisanship does not affect how much people like Hillary Clinton. We're saying we reject that. We have found that partisanship does affect this, and we would expect that, right? That's not a very surprising finding. And then finally, the R squared, which is all the way up here. Wow, the R squared is 0.504. So we move the decimal every time we interpret this. Partisanship is explaining about 50.4% of the variance in the Hillary Clinton thermometer. That is a lot. So remember, this thermometer that goes from 0 to 100, people rate her many different ratings. There's a lot of variance. We're trying to explain why some people don't like her and some people do like her, which means we're trying to explain that variance. Partisanship is explaining 50% of what is going on in these ratings. For all the possible explanations for why people could like or dislike Hillary Clinton, partisanship alone is explaining 50% of this. That's very big and frankly expected because partisanship is a very important variable. So that is how we would interpret this. If you guys have any questions about interpretation, just let me know. I am happy to answer them. But until next time, I'll see you guys and have a good day.